So today we're going to cover gradient of a line, parallel gradients, equation of the line will kind of come into all of that anyway, and we will look at distance between 2 points. Okay, I'll then give you some practice questions as usual, and you can go away and have a look at those. So here we go. We're going to start, first of all, just go have a quick look at the formula booklet. Okay, so everybody gets the same in terms of standard and extended for the formula booklet on linear functions. So you get the coordinates of a midpoint, you get the distance formula, so the distance between 2 points. It's really important to remember that that is there for you. This is quite a common question that comes up, but don't worry about having to remember that formula. Okay, you are also given the equation of a straight line, both in the format of y equals mx plus c, but also this format too. Now, the ax plus by plus d equals 0 is slightly more challenging of a format, but you do need to be familiar with it and just know how to rearrange the two different types, okay? And then, of course, we have the gradient formula, which is basically rise over run. Hopefully you are familiar with that now, okay? So the first thing we're going to look at today is gradient, okay? Okay, so linear functions, we can have a positive gradient, we can have a negative gradient, okay? So the key bits to remember, your positive gradient goes in an upwards direction, okay? So looking from left to right, it will go in an upwards direction. Your negative gradient is basically the opposite of that. So from left to right, it goes in a downwards direction. Okay, now the format of the equation, y equals mx plus c, okay, you need to know that m is your gradient, okay? So m is always the gradient, okay, and c is your y-intercept, okay? So if you need reminding what the y-intercept is, well, your y-axis, okay, is your vertical axis, so this bit here, and your y-intercept is going to be where your line crosses that y-axis, okay? So if I look at this graph on the left-hand side, so I'm just looking here, I've got the equation y equals 2x plus 1, okay? We can see here where it crosses the y-axis, that would be at the point positive 1, okay? Equally, if I look at the right-hand side, we've got y equals negative 3x plus 2. So again, my y-intercept, so where it crosses my y-axis, would be at the point 2, okay? That should be the point 2, and it's positive, so it's plus 2. Okay, I've given you those two examples also in the other format that you can see. So this format underneath them, so 2x minus y plus 1 equals 0, that is the exact same line, okay, just rearranged to be set equal to 0. Okay, so you might be able to see that all I've done is taken y from both sides, okay? Leaves us with 0 is equal to 2x minus y plus 1. Okay, same thing on the right-hand side. I've subtracted y from both sides to get my standard form, okay? So yeah, okay, main thing to take from that is your positive gradient, negative gradient, and how to identify the gradient and the y-intercept from the equation of a line, okay? We're going to do some more practice on this, so don't worry. I'm just going to give you 30 seconds to just finish taking whatever notes you need to take, okay? I have had feedback that I go quite quickly, so I'm trying to be mindful of that, but also I don't want to take too much of your time, okay? I will, of course, post all of the notes, etc., like I have been doing, and I'll upload the video as well, so you can always go back over this if you need to. Okay, so what we're going to do now is just practice finding the equation of a line when we are given the graph of it. Okay, so we're going to start with this one on the left-hand side. Okay, so I want to be left with an equation that looks like this. So y equals mx plus c. So the first thing to look at is our gradient. Okay, a couple of different ways to find this. You could pick 2 points and use the gradient formula, or you can draw a triangle underneath. Okay, now I'm going to use the gradient formula purely because in your eAssessment, you won't necessarily have the ability to draw on the screen and draw a triangle. So let's pick 2 points. So we'll pick here, and I'm going to pick this point here. Okay, the reason for doing that, they have to be exactly on a grid line. Okay, so where the grid lines intersect, the line has to go exactly through that middle point of it. Okay, for example, I can't use this point here. That's no good to me because that's like in the middle and I'm not 100% sure what that point would be. Okay, so the 2 points that I've picked are going to be 1, 2. So 1, 2, and then I've got 0, -2. Okay, and I'm going to use those 2 points in my gradient formula to find out what my gradient is. Okay, so I would write m is equal. Now, y2 minus y1, I've got 2 minus -2, and I'm dividing by x2 minus x1. So 1 minus 0. Okay, now lots of people will ask, does it matter which way round? It doesn't, okay, as long as your x1 and y1 are the same coordinate. Okay, so let me just label which way round I did it. I said this was x2, y2, and this was x1, y1. Okay, so the x2, y2 has to be together, and so forth with x1, y1. Okay, so let's go ahead and calculate the gradient. We've got 2 subtract -2. Okay, I've got a double negative here, so it's going to become a positive. So 2 plus 2 is 4 over 1. 4 over 1 is, of course, just 4. Okay, so I know my gradient is 4. So in terms of my equation, okay, so far I've got m. I need to know what c is. So I can go ahead and write y equals 4x. I now need to decide what my c value is, which is going to be where it crosses the y-axis. Okay, so remember your y-axis is your vertical axis. We can see that it crosses at -2. Okay, and that is your equation. Okay, I would like you to have a go now at the one on the right-hand side. Actually, no, sorry. We'll do this one together and then I'll let you have a go at the next one. Okay, so again, we're going to pick 2 points. Okay, I'm going to pick this point here because I can see it goes exactly through the grid lines. And I'm also going to pick this point here. I can see there it goes through the grid lines like I need it to. Okay, so for this line on the right-hand side, we would have m is equal. Now, let's just think about what the coordinates are. So this here is going to be 0, 3. And this other coordinate would be 6, 0. Okay, let's call this x1, y1, and then x2, y2 here. Okay, so y2 is 0. We've got 0 subtract 3. And we are dividing by x2, which is 6, minus x1, which is 0. So in terms of answering that, we have -3 over 6. And we can simplify that further. It would be -1/2. Okay, now I know that that must be correct in the sense that it's a negative gradient because this line is going in a downwards direction. Okay, so let's plug that into the equation. We would have y equals -1/2x. And then I need to fill in my c value. So again, I want where it crosses the y-axis, and it crosses the y-axis at 3, and it's positive 3, so plus 3. Okay, that would be the equation for that line on the right-hand side. Okay, so I'm just going to give you 20 seconds to finish copying that down, and then I'm going to let you have a quick go at one of these questions on your own. Okay, so the question I would like you to have a go at is here. So I'm just going to time 1 minute. If you're watching this as a video, you can just pause at this point. Okay, right, I'm going to quickly start going through this, and let's see how you did. Okay, so the first thing I want to do is pick 2 points to find my gradient. So I've got 2, 4, and I've got 0, -2. We'll call this x2, y2, and then x1, y1. Okay, so my gradient is going to be equal to 4 subtract -2, all divided by 2 subtract 0. So that would give me 6 over 2, which is 3. Okay, so I know the gradient is 3, so I've got y equals 3x. And then again, I'm looking to see where does it cross my y-axis? Well, it crosses at -2. So y is equal to 3x minus 2 would be the equation of this line. Okay, very well done if you managed to get that. We are now going to move on to just finding the gradient when we're given 2 points. So hopefully this will be nice and straightforward. We've had a little bit of practice using this formula already. So if you are just given 2 points, just remember to label them first of all. So x1, y1, x2, y2, and then you are just substituting in to the formula. Okay, so y2 is 12, m is equal to 12 minus 2 divided by 5 minus 0. This will give me 10 divided by 5, which of course is 2. Okay, for the next one, same rules apply, okay? So you are going to label your coordinates first. I appreciate that you can't label them in the actual eAssessment, so I would jot them down on your scrap paper and label them, okay? And that way you shouldn't get confused, okay? Then we're just substituting in to the gradient formula. So y2 is minus 4, subtract 8, and then we would have 4 subtract -2. Okay, so on the top, -4 take away 8 gives me a -12 over 4 subtract -2. Now remember that's double negative, so we're going to add them. So over 6, -12 divided by 6 would give me -2. Okay, your turn. Have a quick go at that last one. So you've got the point 3, 7 and 7, 19. Okay, so just have a quick go. I'll give you a little bit of time for this. Okay, so hopefully you labeled your coordinate first, and then we are substituting in to the formula. So y2 is 19. We are subtracting 7, and then we are dividing by 7, subtract 3. Okay, 19 take away 7 is 12. 7 take away 3 is 4. 12 divided by 4 leaves me with 3. So our gradient would be 3. Okay, right, we are going to move on now to parallel lines. So the main thing that I need you to note here is that lines are parallel when they have the same gradient. Okay, so if that number in front of the x is the same, the two lines are parallel. Okay, so I've given you an example here of two lines that are parallel. They will never meet, okay? So they both those lines have the same gradient, but what they do have is a different y-intercept, okay? Same gradient, different intercept, okay? So just a quick question for you. I want you to look at the lines that we have in this box here. So we've got 7 different equations of lines, and I want you to see if you can pick out which 2 would be parallel. Okay, so just have a quick look and see if you can see the 2 lines that would be parallel. They have to have the same gradient. Hopefully you have picked out y equals 3x plus 2 and y equals 3x minus 2, okay? Both of those lines, would be parallel, okay? You can see they both have the same gradient of 3, okay? But their y-intercept is different, okay? So a bit more practice on parallel lines. Slightly more complex kind of question that you might get asked, okay? So write down the equation of each of the following lines, parallel to y equals 2x minus 1 and passing through the point 1, 8. Okay, so what we've just learned there is that parallel lines have the same gradient. So I know that the line that's parallel to this is going to have a gradient of 2. So m is equal to 2. I also know that it goes through this point 1, 8. Okay, so I know that when x is equal to 1, y is equal to 8. Okay, so what I'm going to do now is I'm going to plug that in to my equation of a line. So we've got y equals mx plus c. And we know that y is equal to 8. The gradient m is 2. I know for this particular point, x would be equal to 1. And then we need to work out what our c value would be. Okay, so at the minute we have an incomplete equation of a line. I know the gradient is 2x, but I don't know the c value. Okay, so let's figure out what c must be. We've got 8 is equal to 2 plus c. Let's subtract 2 from both sides. So we would have 6 is equal to c. Okay, once you've found your c value, you can just plug that into your equation. So we have y is equal to 2x plus 6. Okay, and that would be your equation of the parallel line to 2x minus 1 at the point 1, 8. Okay, right, can you have a go at this question on the right hand side using the same method? Okay, so pick out your gradient. You know what your x value is when y is equal to the same point. Okay, so you've got x is 1, y 1. So m equals 3. And when x is equal to 1, y is also equal to 1. Okay, so plug that into your equation and see if you can find what c must be. If you're still struggling, don't worry, I'm going to go through this now. So what we would do is we would write our equation, so y equals mx plus c, and let's fill in what we know. So we've got y is equal to 1, so 1 is equal, m is 3, so 3 lots of x is 1 plus c. Okay, so 1 is equal to 3 plus c. So I can subtract 3 from both sides to isolate c. So I'd have minus 2 is equal to c. Okay, so I'm going to plug all that back into my equation of a line now. So I've got y is equal to 3x minus 2, and that would be my final answer for that question. So hopefully you did okay. We are now moving on to the distance formula. There will be more practice of this in the questions that are sent out, okay? So let's keep going. Okay, so the distance formula is one of the things that, to be honest with you, students often forget that it's given to you. Okay, so please remember that it's in the formula booklet, and all you are doing is substituting into the formula. Okay, you've got a calculator and things like that, so as long as you can substitute incorrectly, you'll be able to get the correct answer. Okay, so first thing you want to do again is label your coordinates. Okay, so x1, y1, x2, y2. Okay, trying to find the distance, so we have d is equal to the square root. Okay, so then it says x1, so that's 1, subtract x2, which is 5, all squared, plus y1 is 2 minus 5 all squared. Okay, so I'm just going to keep showing all of the steps of working here. So let me simplify a little bit. So 1 subtract 5, that gives me -4, and I want to square that. And then I'm adding 2 subtract 5, which is -3 all squared. Okay, now when you square a negative number, you get a positive. So -4 squared is 16. -3 squared is 9. Okay, so what we really have here is the square root of 16 plus 9, which is 25. The square root of 25 would be 5. Okay, and that would be your final answer for that question. Let's just do one with negatives as well as an example. So again, labeling your coordinates, x1, y1, x2, y2. Okay, I think with this type of question, the thing just to be careful about is your negative numbers, honestly. But like I say, you've got the calculator, so just make sure you input into the calculator correctly, and let it do it for you. Okay, just remember to show your steps of working. All right, so we have x1, which is -3. We are subtracting x2, which is 1, and then we are squaring. You're then adding y1, which is 4 minus -2. So that's where you need to be careful, where you get those double negatives. Okay, and then we're going to square that. So next step of working, I would have the square root of -4 all squared plus 4 subtract -2 will give me 6. Okay, all squared. So that's going to be the square root of -4 squared is 16 plus the square of 6, which is 36. So d is equal to the square root of 52. Now, at this point in a question like this, you'd probably be told either to give it in terms of surd form or as a decimal to so many places. Okay, so we're just going to do a decimal to two decimal places, sorry. So answer to 2 decimal places. You would put this into your calculator. You would get 7.211, which of course approximates to 7.21. Okay, and then that would be your final answer for that one. Okay, just 30 seconds before I move onto the final slide, which is our exam practice. And then I'm going to distribute the various materials and let you go away and have a go at them. Okay, moving on to our exam practice. So again, this is taken from an eAssessment. Okay, this is in your work booklet. So what I'm going to do is I'm just going to go through the very first equation, and then I'm going to let you go away and have a go at the other two. Okay, so the first thing that I would do with a question like this, okay, so you want to select the line equations and place them with the corresponding graphs. So you basically need to match up these equations with the correct graph. Okay, so remember that it's always in the form of mx these are in the form of y equals mx plus c, where c is your y-intercept, okay? So I would look at these three equations, and I can see that this one is the one that's different, okay? This one has a y-intercept of -1. And when I look at my three different graphs, the only graph that goes through -1 is this one here, okay? So I don't need to worry about the gradient. I know that it has to be y equals 1/2 x minus 1 here. Like, this has to be that graph because it's the only one that goes through -1. Okay, I'm going to let you go away now and decide which way the other two go. So this time you will need to think about the gradient because they both go through the same point on the y-axis. But yeah, just have a think about what gradient means and see if you can answer this question logically without having to pick 2 points, etc. Okay, so that does conclude the class for today in terms of the lesson.